Alright, so today we're going to be doing 10.2, which is going to be determining probabilities. This is where we bridge between Venn diagrams and how we use them to help us determine probability. So let's talk a little bit about what probability is. You've probably seen it before, like you have a 50-50 chance of flipping a coin and getting a heads versus tails. Probability is using data that's given to you in a collection to determine how likely something is to happen. Okay, that's essentially what it is. So we're going to use data to calculate probability. Alright, so the first set of data we're going to look at is some data from an ice cream shop. Okay, they have 2 new ice cream flavors that they're testing out, and they had X number of people trying out these flavors. So here's the data that we know. 2 scoops found that 32 customers liked chocolate cherry, 58 customers liked raspberry ripple, 12 customers like both flavors, and 47 like neither flavor. So we're going to use the Venn diagram to fill this in. So you always want to work inside out based on the data given to you, typically. So how many people liked both flavors?
12.
Good. And how many people liked neither of the flavors?
47.
So that's going to go outside of the circles. Okay. Now, we know that 32 people liked chocolate cherry, but how many people are already in the chocolate cherry circle?
32.
12, so we need to do 32
Plus 12.
minus 12
I'm done with
to figure out how many people are going to go in that part of the circle. Very good, 20. And then 58 people liked raspberry ripple, but how many people are already there?
12.
So there's only going to be 46, okay? So that's a very, very important concept throughout this lesson. Think of this as a realistic circle on the floor, okay? Let's say I gave you all this ice cream flavor to try out. You would go stand in one of those circles, and I would determine 32 people were in the circle for chocolate cherry, but 12 of those specific people were in the circle, part of the circle that overlaps. Okay, so you never want to double count inside the circle. Yes?
So the total is 32? Or what is
The total for circle of chocolate cherry is 32.
My confusion is, okay.
So now we're going to figure out how many customers were surveyed in total, and you can figure that out by adding up these 4 numbers together. Okay? Which means there's 125 customers surveyed. Okay? So the reason we want to count it after we set up the Venn diagram and not prior is because you don't want to double count that 12. You know what I'm saying?
Yeah, that's another question I had. So, like, because it's 12, wouldn't it be 20 plus 12 plus 46 plus 12?
No, because you'd be double counting those people. Because these are only 12 people who happen to like both flavors.
Okay, so but wouldn't they still count as a second customer because they both
No. So 12 people liked both flavors, correct? That's one. These are 12 people only.
Okay.
And then they still count as part of the 32 who liked the one flavor.
Okay.
And this doesn't say 32 customers only liked chocolate cherry. This says 32 customers liked chocolate cherry. If it said only, then it would be that.
So that's where we got the 46 and the 20 from by subtracting it from the 58.
Correct.
Okay.
All right. So now we're going to do the probabilities. So as for probability, I'm going to set these up as a fraction. I am going to convert a few of them to percentages. I will explain how we do that, but I'm not going to do all the conversions for you because this is Algebra 2. I expect that you have those arithmetic skills. So how many people liked both chocolate cherry and raspberry ripple?
12.
So 12 out of the 125 people would be the percentage of people who liked both flavors. So what you're going to do in the calculator is you do 12 divided by 125 times 100, and that's how you convert a fraction to a percent.
Or you can just do 12 divided by 5 and not cover up the 0 point, and then you get the...
That's true too. If you want to do it that way too, that's fine. However you want to do conversions is fine with me as long as you do it correctly. How many people like only chocolate cherry?
20.
Good. And like I said, I'm not going to do all the conversions, so let's write it out as a fraction. How many people did not like chocolate cherry?
93.
Very good. So 46 people who only like the raspberry ripple, plus the 47 people who didn't like either flavor, correct? How many people liked only the Raspberry Ripple?
46.
Good. How many people don't like either flavor?
47.
Good. How many people in general like chocolate cherry? 32. Because they didn't say only, they just said liked. How many people do not like red raspberry or Raspberry Ripple, whatever it is?
67.
Good. We have the 20 people who only like the chocolate cherry exclusively, plus the 47 people who liked neither flavor. And then lastly, how many people in general like the Raspberry Ripple?
58.
Good. Alright, so how does everybody feel about this slide? Does everybody understand where those numbers came from?
Yeah.
Understand the logic between only liking something versus just liking it in general?
Yeah.
Alright, cool.
Yeah.
So now we're going to do a 3x3. So it's really important that you understand those concepts before we go into a 3x3. So with a 3x3, you have to be extra careful of the overlaps because there's two sets of overlaps. So you have to really think about this for a minute. So this question tells us we have a total number of students of 500. Now theoretically, I know that you're thinking in your head, well technically a student would have to be enrolled in science and math at this school, yeah. But there could be students who are not enrolled in any of those classes. So just keep that in mind. So let's say we have 500 seniors go into a gym and there's these circles on the floor. And they have to stand in the box that's applicable to them. So how many people are going to be standing in the middle because they study all three subjects?
25.
Good. So 25 of those seniors are going to stand in the middle because they take all of those subjects. Okay. Now we're going to work. We always work inside out as much as possible here. So we also know that 50 study chemistry and math. So how many people are already in the chemistry math overlap?
25.
Correct. So we need to add that other 25 here. Okay. Now, how many people already are in the studying of Spanish and chemistry?
100.
There's 100 total, so there's already 25, so how many more do we need? 75. Everybody see where I got that from? And then next, we have 75 study math and Spanish,
It'll be 50.
so it's going to be 50. Alright, so does everybody see how we got those center ones? Okay, so remember, like I said, you can't double count. That's the most common mistake people make in this scenario. So, 250 students study mathematics. How many people are already in the math circle right now?
100.
Which means we only need to add 150 more to get to 250. 200 students study Spanish. How many are already in the Spanish circle right now?
150.
Good, so how many more do we need to add? 50, because we have to get to 200, correct? How many people are already in the chemistry circle?
125.
Good, so how many more do we need to add to get to 225?
100.
100. So does everybody see how we got those amounts? Now what you want to go back through and do is verify that the circles add up to what they're supposed to add up to.
Which is 500 seniors.
Well, not quite. That's not where I was going with it yet. You want to verify that each circle adds up to what it's supposed to add up to. So math adds up to 250, Spanish adds up to 200, and chemistry adds up to 225. You see that, the circle situation? So if you were to add up all 7 of these numbers, 1, 2, 3, 4, 5, 6, 7, you're going to get 475. So if there's 500 seniors in the gym, how many of them are in none of these circles? 25 of them are standing outside the circles. So that's a scenario where they're not taking any of those 3 classes, correct? Okay, now we have the total of 500. So now we're going to do our probabilities. How many seniors are taking only math? 150 out of the total 500. How many seniors are taking only chemistry?
100.
Good. How many seniors are taking only Spanish?
50.
Good. How many are taking both math and chemistry?
250 out of 500.
No, math and chemistry.
Oh.
These are all three of my least favorite subjects. I just realized that.
So it's 50.
50.
Let's go.
Because they didn't say math and chemistry, but not Spanish. They just said math and chemistry. How many people are taking math and Spanish?
75.
Good. How many are taking Spanish and chemistry?
100.
Good. How many people are taking none of these three subjects?
25.
Good. Yeah, real cool. Alright, how many are taking Spanish and chemistry, but not math?
75.
Good. Now you're looking at the pieces on the outer side. How many are taking math and Spanish, but not chemistry?
50.
How many are taking math, chemistry, but not Spanish?
25.
Good. And how many are taking at least one of these subjects?
25. Okay, I think that works. 475.
475.
Oh,
Good job.
right.
Oh, yeah.
Correct, yeah.
Because there's
Yeah.
25 people not taking, so you can just work backwards. You could either add them all up or subtract 50 minus 25. Alright, so what I want you to think about for a second before we go into